Hey, welcome everyone into the Wells Tech Garage. Thanks for joining me today for this week's episode of CounterPoint. Today we are going to be focusing on a case study surrounding a 2005 Toyota Avalon, and this thing's got an oxygen sensor heater circuit problem, or more accurately, an air-fuel ratio sensor heater circuit problem. Now, these things are very common for issues on vehicles across the board. Heater circuit problems are very common. So you go to the parts store, you go wherever you get your codes pulled, and you end up with, like this car, a P0051 oxygen sensor heater control circuit low bank 2 sensor 1. What does that mean? Do you need a new oxygen sensor? Do you have a wiring issue? Do you have a problem inside of the PCM? We need to be doing some testing instead of just throwing a new sensor at that. First thing we need to determine is what is bank 2 sensor 1 and what does heater control circuit low mean, and what exactly does the heater of the oxygen sensor do? Well, let's start with going over what the heater actually does. Now, on an oxygen sensor or an air-fuel ratio sensor, the heater is a power-fed and ground-side controlled circuit that's inside of the sensor that heats the sensor up. It's a heater. It does exactly the way it sounds. These sensors need to be hot in order to operate. They incorporate a heater to get up to temperature a lot faster, and on many air-fuel ratio sensors, if the heater is not functioning, the air-fuel ratio sensor won't function. So why don't we take a look at the operation of a heater on a sensor. So I have a thermal imager here, and as you guys can tell, in comparison to my hand, our oxygen sensor right now is relatively cold. In fact, at the tip, we're looking at roughly 82 degrees, so we're just a little bit higher than ambient temperature. All right, so what I've got also here is a power supply. So what I'm going to do is I'm just going to hook up power and ground to the heater circuit of this oxygen sensor. And a little rule of thumb for figuring out what is the heater circuit and what is the signal and return wiring. Commonly, and again, this is rule of thumb, on an oxygen sensor and an air-fuel ratio sensor, you will find that the heater circuit wiring will be the same color. In this case, both heater wires are white, and the signal and return wires are black and gray. But that's kind of something to look for. Of course, you'd want to verify in service information and that kind of thing. But in this case, this sensor, they are both white wires for our heater circuit. All right, so I have power and ground hooked up to the sensor now. I'm just going to turn on my power supply. This is just like hooking up to the battery. And let's take a look at what this looks like on the thermal imager. So I'm going to go ahead and lock our temperature in at 97.2, because that's roughly the temperature in my hand. And we can already see there's heat forming at the tip of this sensor. So we're already up to, at peak, over 200 degrees Fahrenheit. So that's the heater's job. The heater's job is to bring this sensor up to temperature quickly in order to start functioning. The sensor will not function when it's cold, and it's hot to the touch right now. So that is what the heater's job is to bring our sensor up to temperature in order to function. And like I said, guys, there are some air-fuel ratio sensors out there that will not function unless that heater's functioning, because some air-fuel ratio sensors can require up to over 1,200 degrees Fahrenheit to be operational. And if your exhaust is at 1,200 degrees Fahrenheit, you have an issue. Most of our exhaust is around maybe even half that. So we don't want, or we do need our heater circuit to make those sensors function. Okay. Now we know what a heater does and how it functions. It needs power and ground supplied to it. Why don't we take a look and figure out what exactly is bank 2 sensor 1? Let's take a peek here. It is possible that vehicles have up to 4 oxygen sensors on them. So I'm just going to go to Google. We're going to go wellsve.com. And this is free to everyone, guys. All you got to do is go out here, and we're going to look up and figure out what sensor is what on this engine. So I'm going to go to our search parts catalog, and then I'm going to scroll down, and I'm going to grab the year. This is, again, an 05 Toyota And we're working on an Avalon. So one nice thing about these newer scan tools is you have access to the internet right here. So you don't even have to get off your scan tool. After you pull, your code and you get a P0051, a quick jump onto another tab out to the internet, you can determine what sensor is bank 2 sensor 1. All right, so we're going to scroll down here and we're going to go to firing order. And we're working on a Toyota car 3.5 liter. I'm going to click view. This will download. And there's a picture of our car. This is an 05 to 16 Toyota 3.5 liter. And here we go. Here's a picture of our V6 engine. And as you can see, we have cylinders 1, 3, and 5 on the back side and 2, 4, and 6 on the front. Now, anytime you see cylinder 1, that is going to be bank 1. Anywhere you see cylinder, well, no, that's not quite accurate because Ford runs cylinder 2 right next to cylinder 1. But bank 1 will always include cylinder 1. Bank 2 will always be the other bank. So if we're looking at, according to our scan tool, we are looking at, that was bank 2, sensor 1. That is going to be the front bank. That is going to be the front bank, front sensor. Sensor 2 would be the one that's going to be after the catalytic converter on bank 2. So we're going to be replacing the frontmost sensor, and that guy lives right here. This is our bank 2 sensor 1 on this 2005 Avalon. Now this one is nice and easy to do, fortunately. The backside one, you actually have to rip the entire wiper cowl off like I have removed currently to get to the bank 1 sensor 1. And then both sensor 2s are from the bottom. As you can see in this picture, they are very close together. Those are bank 1 and bank 2 sensor 2. Okay? Let's take a quick look at a wiring diagram for this sensor. All right, so according to our diagram here, we have 2 wires going back to our PCM, A1A plus and A1A minus. Actually, let's go ahead and go like this. All right, so we have bank 1 sensor 1 and bank 2 sensor 1. So we're going to focus, because our code is for bank 2 sensor 1, we're going to focus on this one. So these 2 wires right here, pins 3 and 4, these are the wires that are for the signal. Okay, this is for what's actually working on, or doing the work of our action sensor. It's going to be, let's draw them in green, it's going to be these 2 wires. These are our heater. Okay? So those are going to be our heater circuit. So our heater is going to be ground side controlled by the PCM down this wire. So on bank 2 sensor 1, that is going to be a black wire. And then our power feed coming in is going to come in through this shared splice, and it's actually going to feed both of our front bank, sensor 1s are both going to be fed by the same power feed through this splice right here. So being that we don't have a code for bank 1, we know that our power supply, at least to this splice, is okay. So what do we do at this point? We need to determine if our sensor's bad, if our wiring's bad, or if our computer is bad. Well, there's a couple different tests we can do. Now, a heater circuit is kind of just like an element in there that should have some sort of resistance value on it. So we could check resistance on our sensor. So I'm going to go ahead, I'm going to unplug our connector here. And you can see we have our connector right here. And I'm just going to take an ohm meter. And you guys should be able to see that. Tilt it down a little. All right. So I'm just going to check my leads quick. Good to go. And I'm going to go across the 2 wires. Now, again, this sensor, you can see we have a blue wire, a white wire, and 2 black wires. Our 2 black wires are going to be our heater wires. Again, they're going to be the 2 same colored wires. So one on there, and we have nothing. Check it again. Oh, 2, 3 million, 30 million. So we have very, very high resistance. That circuit would pretty much be considered open. According to Toyota, we should see a spec of 1.8 to 3.5 ohms of resistance at 68 degrees Fahrenheit. I have a new sensor here. This is our part number SU10757. And again, the same thing, 2 black wires, a blue wire, and a white wire. Let's take our new sensor and just do the same test very quickly and see what our new sensor comes out at. 2.6. That is between the 1.8 and the 3.4. This new sensor obviously is passing, and I would hope so. It's a brand new sensor. So we know now that our heater circuit on our oxygen sensor or air-fuel ratio sensor is bad. But is the computer okay? Is the wiring going back to the computer okay? At this point, we're not certain of that yet. We could put the new sensor in and it might fix the problem, but I would rather be certain that it's going to fix the problem. We don't have anything else going on this vehicle. So put your ohm meter away at this point, and I'm just going to grab a test light. Again, you don't need any sort of special tools to do this. A simple incandescent bulb test light will work just fine. You could even use a headlight bulb or something like that to load test the circuit. But what I want to do is I want to first of all verify that I have power going to this thing. So 1 lead of the test light onto battery negative, and then we want to hook up to the power feed in, which according to our wiring diagram is the yellow wire. We should see, and I'm going to use a small acupuncture probe on this because you don't really want to go stabbing your test light into here. You could end up wrecking the terminals of your circuit. So as you guys can see, our test light is lit up nice and bright, beautiful. We are sending power, and it is flowing current to our sensor. So our battery plus coming into the sensor is okay. Now what we got to do is we got to check our ground side. Now there are going to be some vehicles out there, and this is going to be the black wire, so the one right above it. There are going to be some vehicles out there that will ground the oxygen sensor when the key is just turned on. All right, so I got this in here. Now because we're checking ground side, I'm going to hook the test light up to power, and I have nothing. I have no power whatsoever. All right, so it doesn't look like our sensor is being grounded right now, or we have an open wire between the computer, or the computer is bad. So what I want to do now is I want to go ahead, I want to start this thing up, and actually what I'm going to do is I'm just going to look at both sides of our sensor. So I'm going to put the green test lead here into the positive of the sensor, battery positive, and the blue one into ground, and now I'm just going to take and hook up the test light across. Alrighty. So, of course, still no circuit, and if we go to ground, you can see we have power. So what I'm going to do, I'm going to go ahead, I'm going to fire this up. I want to bend this out of the way a little bit just so I don't have any accidental contact here. I'm going to fire this thing up, and we're going to see if our computer is going to attempt to turn on the heater circuit of our oxygen sensor. If it turns on and we get ground side control, then we're all done. We put a new sensor in and we're finished. But if it doesn't, well, then we got to determine if we have a bad wire or a bad PCM. So I'm going to go ahead, I'm going to start this thing up because for whatever reason, Toyota decides not to apply the heater circuit with just the key turned on. All right, so our vehicle is started up. What we're going to look for now is our light to turn on. And there we go. We have a flashing light. That is because the computer is actually pulsing to ground. This is going to be a pulse width driven heater circuit. What happened here? All right, so right now it looks like it's gone, right? We no longer have our test light flashing. And guys, that is the computer trying to protect itself, okay? If you're running into that, if for whatever reason you think that your computer circuit isn't functioning properly, grab your scan tool, go back in to your diagnostics, clear the code. All right, so I'm gonna press yes, and I'm gonna clear the code. Now watch the test light as I clear the code. There it is again. The computer is protecting itself. It doesn't want to run the ground side control of the heater circuit unless it knows it's okay. So it ran its quick test in that whatever 10 seconds, determined that it had a fault, and shut the circuit down, okay? Don't get burned by this. Our circuit is just fine on this vehicle. Our circuit does not have an issue. This is normal for this vehicle, okay? Again, we have our codes coming immediately back up because we have an open circuit. So if I clear DTCs one more time, you'll see our test light will start flashing again. We are grounding right now. We are applying the heater circuit on this engine. And then as we set a code, it will shut off. There we go. Okay, so we proved out very quickly that our heater circuit is functioning. We have power and ground going to our oxygen sensor. The ground side control is actually pulse width driven by the PCM. All we needed was a test light and a voltmeter. But I don't think it's wise to stop after ohming the oxygen sensor. Sure, you ohmed it out and it failed, but what if you had another issue? You know, you don't want to run into a vehicle or your own vehicle where you're constantly trying to fix the same code. So you put an oxygen sensor in, light comes back. You put another oxygen sensor in, the light comes back. We don't want to have those repeats keep coming back. So it's better to verify everything the first time. That way you know next time what to be looking for if it were to come back. And in this case, it's time to throw a new sensor in, and we should be good to go. Now, we have a couple different options when it comes to installing our sensors, right? You could get yourself an oxygen sensor socket, something like this. It's got a groove cut in the side, and it's intended to fit over the sensor with the wire hanging out. Now, the downside to something like this is the fact that it could end up spreading open on a very, very tight sensor, a sensor that would be rusted in. Some oxygen sensors will require heat applied to the exhaust manifold in order to get them out. Sometimes you have to get that nut almost cherry hot just to get an oxygen sensor out. Now guys, what I like to do, I've already determined that our sensor's bad, right? I'm going to go ahead and I'm going to pop this clip here so I can get the harness out of here. All right, so now our harness is out of its retainer, and we've determined that our sensor's bad, right? So we're not going to be reusing the sensor. The sensor is junk. What I like to do, so I get the best contact on the sensor and don't risk stripping it out, I like to cut the old harness off. Guys, just the side cutters here, but just know, when you cut this thing off, make sure that you're not plugged in. If you're plugged in, and as you cut all 4 wires at once, you could short power to ground potentially, and you could end up blowing your fuse, okay? So just a quick snip on there. Now you should be able to get a deep well 1/2-inch socket on there, 7/8 socket. You should be able to get that on that sensor, a full regular socket, and get the best bite on that sensor as possible. And this one comes out pretty nicely. That wasn't all that tight on this one. But there are going to be some out there that will really cause you some headaches. So that's why I like to use this. That's why I go this route, just to help prevent any sort of issues down the road. Now be careful when you get your sensor out. If you've been running the vehicle, it is going to be very, very hot. So there's our old sensor, and it looks like we're ready to put our new one in. Now our new one, you'll notice when you take it out of our box, you'll find the anti-seize is already installed, as well as a small gasket that's on here. Don't put more anti-seize on, and never ever get anti-seize on the tip of the sensor. You will ruin it, okay? So there's plenty of anti-seize on these threads. I'm ready to thread this thing in and tighten it down. All right, and as you can see, as I'm tightening this thing down, I'm twisting the wire with it. I don't want to go plugging this into its connector and its hold down, because I don't want the wire being twisted as I'm installing it. I always want our wire to be free until the sensor is tightened down. I'm going to take that sensor socket. I'm just going to go over our sensor, and I'm going to grab my ratchet and an extension, and we're just going to snug this thing down. Torque to factory values. Click, 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 and there we go. Our sensor's tightened down. Now it's time to just simply put it back into its harness. Hold down here, and you always want to be using these hold downs, guys. These are keeping our harness out of the way of harm. And plug it back in. And clip this connection down, and we should be good to go. All right, our harness is in. We have enough wiggle room in here. Harness is plugged in. Now, before I go starting this thing up, guys, I'm going to quickly clear codes out of this thing. That way our heater circuit should become functional almost immediately. So I'm just going to do a quick key on. And press OK. Let's go back into trouble codes. And we'll see what we got here. We'll go ahead, clear. Alrighty, no fault codes detected now. So our codes are cleared. I'm gonna go ahead and fire this thing up, and let's see if this thing heats up as the vehicle warms up. All right, we'll go ahead and let this thing adjust. The camera will calibrate. Again, we're looking at our engine as a whole right now is pretty cool. You can see the camera's actually auto calibrating. Watch the right side of it. You'll see the temperatures changing. But you can see our exhaust manifold right now with the little don't touch hand is relatively cold in comparison to our oxygen sensor itself. You can see our oxygen sensor is significantly hotter than the surrounding exhaust manifold. All right, so to me it looks like we have a functioning sensor here. Our heater circuit looks functional. We should be good to go. All right, let's just check our codes one more time, make sure that we don't have any pending heater circuit problems, and I think we'll be good to go. So you can see no fault codes detected. Go ahead and shut this thing off. So I think that's going to be about it, guys. Real simple. Ohm out your heater circuit of your sensor. You can usually find a spec online. You could also potentially find it out on our website. In addition to ohming out your old sensor, you're going to want to go ahead and just verify power and ground feeding that heater circuit. You always want to be checking that. Some vehicles, it will be easier to do it on others. Like this Toyota, it's only going to apply ground to the circuit when the engine is running and when it hasn't coded or set a oxygen sensor heater circuit code in the system. Remember that. Don't get burned by your potential computer protecting itself, okay? Always keep that in mind, that it is possible for our computers to protect themselves and cut the circuit off when it recognizes that there's a fault. Clearing of the codes, it should run through the test very quickly, and you should be able to see that command happen for ground, and like we showed with the test light, it functioned normally. So, all right guys, I hope you enjoyed this episode of CounterPoint where we went over the heater circuit on an oxygen sensor or an air-fuel ratio sensor, because they are very common codes. Hopefully you put this to use next time you run into these codes on your vehicle. So thanks again for watching. If you like what you saw, please give us a thumbs up, subscribe, share our videos wherever you'd like, and also check us out on social media, Facebook, LinkedIn, Instagram, and Twitter. The links are going to be down below here in the description of the video. So appreciate you guys watching, and we'll see you guys again next time in the Wells Tech Garage. Thank you. Happy wrenching, everyone.